your top half. Like, your head is like, it's like right here.
Yeah, you did to me.
That was good. Alright guys, what I need you guys to add, on the one that was writing Ionic formulas, I want to add something to this. So everyone find the very last step on writing Ionic formulas. Yes. So it should be the very last page? Okay. What you guys need to add on that darkest box on there, the very last box, the one that says, check your guys' answer. Okay, what I want you guys to do on there is that underneath that box, I want you guys to write, reduce the subscripts if you can.
Well, I can't do it below it.
And it should be typed in there for you guys. So add on there, reduce the charges if necessary.
Reduce charges or subscripts?
The subscript, sorry, that's what I meant. My bad. Someone said that to me and then I got confused. I blame someone else and not myself.
If possible?
If possible, reduce your subscripts.
I'll save this.
Oh, what am I doing? That's the green one. I need to continue on my yellow.
If possible or needed.
If needed and or possible. If you guys can't do it, don't make fractions or anything. Okay, what that looks like then, guys, is this. How does that look?
It's actually pretty good.
Okay, cool. What that would look like is if we had, let's take for instance, manganese. I see this one a lot with manganese. So manganese, if we look at our periodic table, can have a charge of 2, 3, 4, 6, and 7. Okay? In this case, let's say our name was manganese 4 oxide. Okay? So we would find manganese has a charge of 4 positive, oxygen is 2 minus. If we put those together, will they cancel out? No, so what do we got to do? Crisscross them. So the 2 would go down here, the 4 would go down here. So you guys' formula would be Mn2O4. We look at 2 and 4 as our subscripts. Can we reduce those? Okay, so if we reduce it, what would this final formula be? MnO2. Okay, so that's going to come into handy when we're talking about going backwards. We're going to do some examples since we finished up the notes on writing or giving the names, naming the ionic formulas. We're going to take a look at some of these examples that we might see something like MnO2. Okay, so let's take a look at examples. Let's flip back to then, naming ionic compounds? Yeah. What we finished off on yesterday. Yeah, duh. Naming ionic compounds. Wow, brain's not working so solidly to say. Okay, same thing you guys want to add to this somewhere on there. I want you guys to write that only ionic compounds with an ATE or ITE or polyatomic. Okay, with your exceptions of hydroxide, cyanide, and ammonia. Okay, ionic compounds with only 2 elements are going to end in IDE. So if it just has 2 elements in it, it will end in IDE. That will be the biggest indicator for you guys. It is also a test question. What does it mean if it's ionic and it ends in IDE? Okay, it only has 2 elements.
Are we on naming or writing?
We're on naming.
Oh.
Naming ionic compounds. We were just on writing, but we came back to naming. I just wanted to tell you guys the reduce part. Okay, because it's going to come into play here. Okay, and then again, we never see prefixes unless we use a polyatomic ion that has a prefix like dichromate has a prefix. Okay, but that's just the name of the polyatomic ion, so we didn't add that in there ourselves. Was anyone gone yesterday? So no one's like completely lost right now. I had 3 kids gone in the last period, and they were like, What, huh? Because we didn't finish the notes either, so it was literally like we picked up in the middle of that last flow chart. I just kept going, and they were like, just throw their stuff and walk out.
Is that an option?
No. You were here. Physically, you were in my class, and so that is not my problem anymore. All right, guys. Oh. Grace, I'm thirsty. Will you give me my water bottle? I'm joking. I can catch. Just joking. I'm a catch. Oh, sit down. I'm joking. I'm not even thirsty. I'm not even thirsty. My voice is so hoarse. that would have really sucked. That would have hit me in the face on video. That would have been a YouTube win. That would have been the only time I became a YouTube sensation, is when the giant bullet of a water bottle nailed me in the face. Oh, God. You know that would be shared on, like, everyone's Facebook. Like, I don't even care what Miss Crawford talked about in that 10-minute video, but did you see her get just smoked in the face with that water bottle? It's a heavy water bottle. It's solid. All right, let's do some examples. So I have 5 examples for you guys. Okay? So first thing, obviously we know these ionic. So even though I don't like to say this, we're just going to skip the first question that says, is it metal or non-metal or 2 non-metals? Like Friday when we start doing some random stuff, you guys are going to actually have to start paying attention to that. Which system are we using to name? Are we using prefixes? Or are we doing this ion junk? Okay? So we look at this one. All right, the next question after that is we're going to assume all of these are ionic. Okay? What's our next question, Libby? What are those special metals? So instead of just making the list, what do those metals mean, Buck? What about them? Is it any transition metal?
Only the ones that have like one charge.
Right. We call them multivalent. There are transition metals that have more than one charge. So like even though zinc is a transition metal, if you guys look above the symbol, it only has a 2. Okay, so zinc is only ever going to be 2. So with something like zinc, we are not going to have to specify. But with magnesium, are we going to have to specify? No, it's magnesium. It's always a 2 plus charge. Okay? So with that being said, we go into the next step, which just says, write magnesium. Magnesium. Okay? Our next question asks us, is this 2 elements or is it more than 2 elements? Rachel? It's only 2. So you guys go the no route. It's only 2. No, it's only 2. Okay? We look at the next one. We write the next element, oxygen. Okay, what does this end in? IDE, so we're going to drop the -gen. Change it to IDE. All of your ionic compounds that only have 2 elements will end in IDE. So if you guys see something that's ionic, it ends in IDE. That's going to tell you right there, it's just a simple metal and a non-metal. There will be 1 to 3 exceptions to that, ammonium, hydroxide, and cyanide. Nope, not unless it's part of your prefixes like dichromate. Yep, you'll never see, and I see kids do that a lot. Oh, magnesium dioxide, or whatever the case is. Okay, nope, no prefixes. Good question. All right, let's go on to this next one. Oh, let me go back and fix this real quick. All right, next question. FeOH3, so we've got a parentheses around our OH. So we know Fe is a metal. Okay, we know it's ionic. Our next question, is it one of those transition metals with multiple charges?
Yeah, it is.
Yes. Okay, I was waiting to get a consensus there. So yes, it is. If you guys look on your periodic table, iron can be 3 or 2. Okay? So how do we know which one it is? We're going to need to specify that in this. So we're going to write iron, and then in parentheses, we're going to need to write a Roman numeral to tell us what charge it is. How do we figure out what charge it is? How did you figure that out, Grace? How did you say 3? Yeah, you are going to want to cancel out the other one, okay? How you guys do this is, when you guys do it the opposite way, you guys crisscross the charges. So to go backwards and write the name, uncrisscross it. The 3 is going to go up here. A 1's going to go up here, okay? So we can assume it's iron 3. Is that an option? Is there a 3 plus charge for iron? Okay, here's the other thing you need to do. This is where it gets tricky, and this is why I told you guys that it's important to reduce if you can. Okay, obviously we're writing the names, so we don't have to worry about reducing, but we need to check the other one. OH, what is OH?
Oxygen.
It's
Jocelyn, what is it?
hydroxide.
See how it's important to recognize those. Okay, so she sees hydroxide, and Jocelyn, she's been studying those every night since I sent out those study cards. Darn too, and so she recognizes it as a polyatomic ion. What charge does that polyatomic ion have? A -1. Is this a correct statement then, that this is a -1 and this is a +3? Yes. Okay, so So we know that 3 is right then. Okay? If we were to say, all right, this is 3 and this is 1, but this is incorrect, that means that this can't be 3, and that we've probably reduced prior to this. Okay? We'll come to a next example that has that case. All right, we move on. Is it 2 elements or more than 2? More than 2. We've got iron, hydrogen, and oxygen. So we know it's a polyatomic iron, which we've already figured out is what? Hydroxide, so we just need to write the name of that. Okay, so your name for this is iron 3 hydroxide. Okay. That's not okay. Oh no. I lost my marker in the pumpkin patch. Alright, next one. Alright, MnO2. Tricky. Tricky. First of all, and I've already seen this on some of your guys' naming, the last worksheet we did with just the covalent, you guys are writing the wrong symbols already. Okay? I don't trust that you guys know the periodic table quite as well as I do. So I need you guys to make sure, I've seen fluorine FL a lot. Okay? It's a common one. Okay? The other common one I see is this one right here. What is that? Manganese, not magnesium. Okay? So make sure you guys are super careful about those things. Okay? So we know, is it one of those special multivalent transition metals that have more than one charges? Yeah, it is. It can be a 2, 3, 4, 6, or 7. So there's 5 different charges for that. We need to figure out which ones. We write manganese. Again, not magnesium. We need to write the charge in parentheses and Roman numerals. Okay? So what do you guys think the charge is? 2. We uncrisscross it, it's a 2. Okay? So our Mn would be a 2. If we uncross the oxygen, what charge would oxygen be? -1. Okay? Let's look at that though. Is 2 plus an option for manganese? Look on your periodic tables. Absolutely. Okay? It's one of the options. So if we wrote 2 in there, is that correct? Why, Tyler?
Because it's been reduced.
How do you know? I meant to change it to tin before this one, actually. Well, what do we know about oxygen? Right. You guys need to check your other one. We know oxygen is a 2- charge. We have it written as a -1, so if we change it to number 2, we've multiplied it by 2. What do we got to change this by? We got to change this to 4. So it's manganese 4. Okay, does that make sense? Always double check your other one and say, all right, is this a true statement? If we uncrisscross this, the metal is this charge, the non-metal is this charge. Are those both true statements? Can the metal be this? Is our non-metal that?
Can we
Okay?
put the parentheses inside the just regular numbers?
No, you guys need to do Roman numerals inside. I can help you with those. Last but not least, it's 2 elements, so it's just going to end in what? IDE, so oxide. So manganese 4 oxide. Okay? All right, another example, 2 more left. K3PO4. Okay? Potassium's a metal. Is it one of those metals with multiple charges, merit? No, it's potassium. Potassium's always a +1 charge. Okay? So we just write potassium then. Is it 2 elements or more than 2 elements, Lib? More than 2, so what does that mean, Tristan, if it's more than 2? It's going to be a polyatomic ion, and most of those are ATE or IT with the exception of hydroxide and cyanide. Okay? So look on your guys' polyatomic ion cheat sheet. Devaney, what is PO4? Phosphate. So we just write potassium, phosphate. So minus all the rules and stuff that we have to go through to get here, I mean, you look at the naming, it is pretty simple. Okay? Why do you guys phosphate me? What's it? What thing? I don't need to. PO4 is 1 unit. We only have one of them. Look on phosphate on your cheat sheet. Notice how it's PO4.
But it's also got a negative 3 charge.
Yeah. If I were to have, like, if this were to be like CA and we would have to carry the 2 down here, now I need parentheses. Okay. Good question, though. Way to try to make me look bad, Libby.
Oh.
Jerk move. Just joking. No, that's good. I'm glad you noticed that. So, okay, last but not least, NH42S. Okay? You guys look at your first question. Is it a metal and nonmetals, or is it just nonmetals? It's just nonmetals. So, are we on the wrong sheet?
No, polyatomic.
You guys need to study your polyatomic ions, because if you do, even if you guys look at that and say, well, those are all nonmetals, you guys are going to recognize NH4 as what?
Ammonium.
Ammonium, right? So that's why I'm having you guys learn those. Is because even though they're in front of you for most of the time, if you guys are able to look at that and recognize it, it'll make your life easier. Hello? Teaching my kids, believe it or not.
Teaching my squad.
Yeah, I'll send her down. All right, bye. Someone registered for Pinedale's ACT. I didn't say anyone. I didn't say anyone's name. All right, guys. All right, so at any rate, you guys should be able to recognize ammonium. Just chill for a sec. Let's finish one. So with that being said, I say ammonium. Okay, ammonium always has a +1 charge, so we don't have to specify anything in parentheses with Roman numerals. Okay. What are we going to end this in, though?
Sulfur. Sulfate?
I hear sulfide. Sulfide's right. Right. Why is it not sulfate or sulfite? It's a single element, guys. Sulfur is a single element. If I put sulfate is SO4. Okay? Sulfite is SO3. This is just S. So if it ends in just a single element, it's IDE. If you guys look on your flow chart, there's a special box for ammonium. Okay? For naming these. Or writing for naming. Okay? That one box, like second to the last, says something about ammonium. If you guys have ammonium, okay, and it's with just another single element and it ends in ITE. If we were to make this SO4, okay, then it would be sulfate. So it just depends on what it's paired with, too. If it's paired with another polyatomic ion, then yeah, it's going to end in whatever the polyatomic ion ends in.
Wait, doesn't ammonium go first in every?
Yep, because it's a positive. Remember, we always put our metals or our positive charges first?
Just for 2, I was like,
Yep. Okay, cool. All right, guys. What we're going to do next is we're going to do a little example. Or let's see, there's 16 of you guys. I need you guys to get in groups of 4. Go.